Yesterday we looked at chance experiments with outcomes that are not equally likely, and today we're going to represent a sample space in a tree diagram and then calculate those probabilities. So a tree diagram is an important way of organizing and visualizing outcomes. It is a particularly useful device when the experiment can be thought of as occurring in stages. So when the information about probabilities associated with each branch is included, the tree diagram then facilitates the computation of the probabilities of the different possible outcomes. So we're going to look more at this tree diagram in this problem below. Imagine that a family decides to play a game each night. They all agree to use a tetrahedral die or a four-sided pyramidal die where each of four possible outcomes is equally likely. And again, we can look at a picture of that later, but it's a die that has equal opportunities for each night to randomly determine if they will play a board game or a card game. So I'm going to go ahead and highlight that they can play a board game or a card game. And the tree diagram mapping the possible overall outcomes over 2 consecutive nights will be developed below. So to make a tree diagram, first represent all possibilities for the first stage, in this case, Monday. So I'm going to just add that annotation. This is stage 1, and this is stage 2. So we can have multiple stages within a situation or an experiment. In this case, they are only playing 2 nights, Monday and Tuesday. Therefore, we only have 2 stages. Okay, so in order to start creating our stages, we know that on Monday, they have 2 options to play. They can play board games or they can play card games. Okay, so they have B for board games or C for card games. These are the only options they have, and therefore Monday is done. So in order to move on to Tuesday, we need to think about what could happen if on Monday they played board games first. So they could still play board games or card games on Tuesday. So in order to represent that, we are going to create branches, hence the tree diagram, from every outcome we've already displayed for Monday. So that means there are going to be branches on B, board games, and C, card games. Because on Monday, they could play board games, and on Tuesday, they could still play board games or card games. Or on Monday, they could play card games, and Tuesday, they could still play board games or card games, right? The options still stay the same. It's just we need to show every possible option that could happen, and a tree diagram helps us organize this information. So now that we have drawn our branches of our tree, we are going to list out the outcome, and it may be a lot easier to use highlighters or colored pencils at this point so we can see each possible outcome. So let's start with Monday. Monday, I could play board games, and I could then play board games on Tuesday. So we would list that as B. So in other words, we would play board games on Monday and Tuesday. So that's how we write it, B. I could also play board games on Monday and then card games on Tuesday. So how would I represent that? Well, I would represent that as B first and then C because we would play board games on Monday and then card games on Tuesday. So that would be second. So again, colored pencils or highlighters will be super helpful here because then we can show the route that we are taking through this tree diagram to represent each outcome. So I've already highlighted the next one. That shows that we could play card games on Monday and then board games on Tuesday. And finally, we could then play card games on Monday or card games on Tuesday. So here are all of the possible outcomes of different types of games we could play on Monday and Tuesday night. So then we have additional questions that says if BB represents 2 straight nights of board games, what does CB represent? So I'm just going to give us some space to write because I did not do that earlier. Apologies. So if BB represents 2 straight nights of board games, then we know that CB represents card games. Since that's first, what night would that be? That would be Monday. And since B is board games and it is second, that would then be on Tuesday. So Monday they would play card games, and on Tuesday they would play board games. And it has to be in that order because we read it from left to right, and the first stage is Monday. Therefore, the first letter relates to Monday, and the second letter relates to the second stage or Tuesday. Finally, they want to list the outcomes where exactly one board game is played over 2 days. And they want us to look at the list where there is exactly one board game, or 1B, in the problem. So let me actually use another pen that we can see. So we're looking for all the outcomes that only have 1B. So that one has 2 B's, this one has 1, and this one has 1. So it doesn't matter what order, they didn't care about the order, but they just wanted to know what outcomes had exactly one board game. And how many outcomes were there? There were two outcomes with exactly one board game. Perfect. So our stamp here, if we look back at our problem, is using a tree diagram can help organize outcomes in a sample space for chance experiments that can be thought of as being performed in multiple stages. So tree diagrams are also useful for computing the probabilities of events with more than one outcome, which we will see a little bit later. So we're going to go ahead and create some more tree diagrams in our Nearpod.